In example 6, we need to graph y is equal to the sine, and then theta minus pi over 3 is in parentheses, and then plus 3. So let's figure out what the period is first. So the period of this is going to be 2 pi over k. K is 1, so this will just be 2 pi, like our normal sine or cosine curves, our parent functions. We need to do the phase shift. So the phase shift is going to be c, which is negative pi over 3 over 1, and I'm just going to leave that as pi over 3. The vert shift, and this may not work out well for me because I've now drawn all over the graph where I'm going to have to be, but we'll see how it works. So the vert shift is going to be just up 3. The next thing we need to do is label our y-axis. Keep in mind that the amplitude here is just 1. So the highest we need to go is 4. Maybe we can make this one worth, well, this is divided up into 3s here, isn't it? So that makes our decision a little bit harder. How about if we do 6, 4, and 2? Those might be nice values to use here. Whoops, that's a negative 4. Sorry about that. And we'd have a negative 6 all the way down here. On the x-axis, when you're going to need to go 1 full period or 2 pi, and we're going to need to shift all the points pi over 3. Pi over 3 is kind of like it's a funky sort of a value. You're not going to see those divisions here unless we specifically put them in there. So let's go with this end being 2 pi. And let's see, this is going to be right by pi over 3, so this may work. We'll see. We can always adjust it if we need to. This is going to be pi over 4, pi over 2, 3 pi over 4, and then we're going to have 5 pi over 4 here, 3 pi over 2, and 7 pi over 4. Over here, negative pi over 4, negative pi over 2, negative 3 pi over 4, negative pi, and if we need to, we can fill this out here as well. Let's plot our top line, midline, and also bottom line. So I know my vertical shift is up 3, and my amplitude is 1. So what I need to do is I need to draw my top line at 3 plus 1. And when you're drawing these, it's nice to be able to try to line up your ruler correctly. And you can look at the bottom of the ruler and look at the x-axis, and that gap should stay the same as long as you're lined up here on the top. So there's our top line. Our bottom line is just going to be 3 minus 1. The amplitude is 1. So our value is here, and this is a little bit harder to keep straight, but now that you've drawn a line, you're good to go. And we want to try to draw about as right in the middle as we can get. So I'm going to make a little mark here. And that little mark is going to be right at 3. That's where our new midline is. So let's see if we can graph that. And your graph might look a little different based on your scale. It's one of the weird things or interesting things maybe about sine curves. You can get them to look the same if you just change the scale. So as long as you're hitting the right points, you're good to go. The next thing we're going to do is we're going to divide this thing up into sections. So we can divide this into 2 pi, and half of that is pi. Half of that is going to be right here at 3 pi over 2. And then pi over 2 is going to be right here. Alright, now it's time to graph without the phase shift. So this is a sine curve. It's going to begin at the midline. It's going to go up first, there's no reflection, come back down, and then go back up. So this graph is going to look something like this here. Okay? Of course it goes on for a long time. This next part is pretty tricky. We have to figure out where pi over 3 is, and then we're going to shift all those points over. So if we look at the x-axis, if this distance is pi, then 1/3 of that, which is maybe right here, And then we could draw another one, and maybe that should be a little closer to pi over 4. Well, let's see, 1/3, yeah, maybe that should be a little bit closer over here. And then we're going to have, let's see, 2 pi over 3, 2/3 is less than 3/4. So that other one's going to be here, and you can see that this distance now is about the same, and it splits pi into thirds, so this distance is going to be pi over 3. And I suppose if we wanted to, we could put those values in here. So this is pi over 3, and this one's going to be 2 pi over 3. Now what we need to do is we need to utilize this distance and shift all of the points. So I'm trying to do this in red. And we want to go right by pi over 3. Maybe I should have put that on there as well, that this is going to be right. We're going to do the opposite of the sign that's here. So if we go right by pi over 3 by this distance, then each one of these points is going to move by about that much. And we can just shift all of them over. We may not be able to shift this other one over, but we can try a little bit, kind of put it off to the side here. Maybe it's that distance. If we continue this graph in orange to the left a little bit, this graph would come down and hit here. So sometimes it's necessary to draw another point and then shift that as well. We want to shift that by pi over 3, so maybe about that distance. And then we can draw the graph from there. So a little tricky. You've got to do some extra things here with that phase shift by pi over 3. The graph is the solution. So this is the graph in red right here. That's the one that you're going to want to write.